The subject of this presentation is vibration of structures in energy engineering. My name is László Kollár, and I'm a full professor in the Szombathelyi Institute of Technology. In this project, we study vibration of transmission line conductors and wind turbine blades. The conductors in power network are suspended in the atmosphere, and they are exposed to such natural phenomena as wind, ice, or the impact of different objects. These phenomena lead to static and dynamic loads due to the high sag, the high amplitude vibration, and in case of conductor bundles, the rotation of the bundle. These loads cause damages, the flashover, insulator breakage, tower damage, or in extreme cases, even the collapse of the tower. These problems justify the effort that researchers made to study this phenomena and to develop line protection methods. When we study this phenomena, we have to develop models where we can reproduce what happens in the nature. The dynamic problems that we model include wind-induced vibrations and vibrations following ice shedding. When wind acts on the conductor, it applies a periodic excitation on the conductor, and it can lead to high frequency vibration as the Aeolian vibration or high amplitude vibration as the galloping. When ice sheds from the conductor, then the conductor releases a high load. It is followed by the jump of the conductor, and it is associated with excessive transient dynamic forces. After during this process, high amplitude vibration develops, but then the vibration decays due to the damping of the conductor. The methodology to study this phenomena is to construct mathematical and numerical models and to carry out experiments in laboratory in small-scale models. There are several methods to attenuate the conductor vibration. We study some of them as listed in this slide. One of them is the application of interface spacers, which helps reduce the high amplitude vibration. Another method is the application of vibration absorbers that contributes to reducing high frequency vibration. And the third method is the application of active control, where we measure a parameter of the conductor, the displacement or velocity of the conductor, and the control force is applied depending on this measured or observed parameter. The goals and the projects in this domain is to study and simulate vibration of transmission lines following ice shedding, and the numerical and experimental modeling of wind-induced vibration of conductors. The other structure that we consider, and that is also affected by the natural phenomena, is the wind turbine blade. Obviously, wind is necessary for the functioning of wind turbines, but ice also occurs as an undesired load on the turbine blade. It leads to a reduction of lift generation and increase in drag, and consequently power loss of the wind turbine. It may also cause limited safety and lifetime of the wind turbine. These problems are also studied by developing mathematical and numerical models and by carrying out measurements in laboratory. These measurements include vibration tests and wind tunnel experiments. The goal and the project in this field is to predict loads on wind turbine blades and study and simulate blade vibration following load removal. Thank you for your attention.